Okay, so the first thing I'm gonna talk about is sooty stuff. Like they will mention about how alkane and alkene can burn in air, and when they burn in air and you have something above the alkane or alkene, the smoke that comes out of it, there will be black spots on that area, like when the smoke reaches it. So that is the soot. The soot actually comes from the carbon. Like for example, kan, if I were to burn chicken, right? Like you know how the black spots will like appear on the chicken? That is the carbon from the chicken. The black spot is the carbon. So the sootiness is the dark things, and that also comes from carbon. So how do we know which one makes a more sooty flame? We have to look at which one has a higher concentration of carbon than which one has a higher concentration of carbon. So how do you do that? We need to try not concentration, percentage. So you can see here that with my very bad handwriting, it's still readable. So that's why I used it. I accidentally cut off number B, 2, and C. But don't worry, I know what the answers are. So yeah. Okay. Well, I'll go with question 3A first. So yeah, if you see this, hi Miss Ho. 3A1, wait. 3A1 is determine the molecular formula of PQRLS. 3A2 is determine the homologous series, and 3A3, what is the functional group? Okay, so first of all, I'm going to talk about how I got this. So number one, they all have 3 carbon atoms. So I know that they have 3 carbon atoms. So they're all prop something. So now I have to know which one, if they're either alkane, alkene, alcohol, or carboxylic acid. So, okay, it says here, does not decolorize bromine water and consists of only carbon and hydrogen. So, if it consists of only carbon or hydrogen, then I know it's either, wait, I'll write down here first, alkane, alkene, alkyne, alcohol, carboxylic acid. So, with the first one, kan, I know it's only carbon and hydrogen, so it's either alkane, alkene, or alkyne. So these two are out. And then it does not decolorize bromine water. So the thing is, right, we talked about substitution reaction. That only happens under sunlight, and if the reactant is gas, not water. So bromine gas or chlorine gas. So that means it cannot react with liquid. So that means it does not decolorize with bromine water. And we know that alkene can undergo substitution reaction, halogenation. And if you look at the UEC book, alkyne can also undergo halogenation. So that means P has to be an alkane. Okay, now Q. Let me just cross that back out. So no one is alkane. This is P. Next, consists of only carbon and hydrogen, decolorizes bromine water. So it's either alkene or alkyne. But since SPM book only talks about alkene, then we answer alkene. After that has molecular R. So it is soluble in water, so it's either carboxylic acid or alcohol. And here's the main part here. It reacts with sodium to release hydrogen gas. So sodium is a metal, and only acids react with metal. So it's carboxylic acid. And last one is reacts with ethanoic acid to produce a compound with fruity smell. Of course, it's alcohol, because only alcohol and carboxylic acid can form ester. So now we know what PQRS are. Then that's how we answer A1 and 2. So how about 3? 3 is basically the functional group. So the way you write it is, the functional group of R is carboxyl group, comma, and then write its thing. So it's COOH or OH. Dash, you have to put the dash as well. The dash shows that it is connected to the carbon atom. It's dash COOH or dash OH. Okay, next. Here's the question that I want to talk about, the sootiness. So the way you want to find out whether P or Q is more sooty is, you know that if you know well enough, you know that alkene is more sooty. But for us to prove it, or to explain why, we have to do calculation. So how do we do calculation? First of all, we need to determine the molecular mass not the molecular mass, the molar mass or the relative molecular mass. You can either do RMM or molar mass. Both also work out of P and Q. So we know that P is propane and Q is propene. So it has 3 carbon atoms and either 8 or 6 hydrogen atoms. So the RMM is carbon is 12 and hydrogen is 1. So times and then plus. Times and then plus. So that 12 times 3, 8 plus 8, 12 times 3 plus 6. So the RMM of propane is 44 and the RMM of propene is 42. So the total RMM is 44 and 42. How about carbon only? So carbon only is 3 times 12, so it's 36 law. So 36 and 36. So of course you have to write it in a more organized method lah. So percentage of carbon in P is 36 over 44 and then convert it into percentage. So I got 81.81% and 85.71%. So the higher percentage means that there is a higher, I guess as I said lah, concentration, like there is a larger presence of carbon in the alkene. So if it has a larger presence of carbon, then it will produce a more sooty flame. So yeah, basically that's how you solve it. The one with a higher percentage is the one that produces more sooty flame. Okay, now how about number 2? What is the complete combustion of P? Let me write it down. So it is, P is alkane, so it's C3H8 plus O2 gas arrow heating CO2 plus H2O. H2O is nominated as liquid lah, because it changes to liquid in the end. But I think steam is acceptable. So we know that propane is gas. And then I think, if I remember correctly, it is gas. So now we have to balance. So there's 3 here. So I put 3 here. Now there's 6 oxygen. There is also 8 hydrogen. So there is 4 H2O. Because 8 and 8. So now we have 4 oxygen and 6 oxygen here. So we have 10 oxygen in total. So we put here 5. Because 10 divided by 2. And then lastly, it's isomers. S has 2 isomers. Determine the structural formula of both isomers S and name each isomer. So S is S is propanol. S is propanol. C3H7OH. So there are 2 answers. Since it has only OH, the only isomers of propanol have to be they cannot be branches because alkyl group is not really applicable for branches. Like I think it works for bigger ones, but for smaller ones no. So we have to use what's it called again? Functional group. The one with the functional group punya name. I forgot the type already. Oh, position isomerism. So what is position isomerism? As I said in the first video or the second video, it is the position of where your functional group is. So propanol is C, and you have this. So I'm just gonna put them as normal first. H. Now, how about this one? You have to put OH in one of these slots. So I'll put one here. Remember to connect to the O, and I'll put one in the middle. So we now have propan 1 all and propan 2 all. And those are your 2 answers, huh? So I guess that is how you solve the question. Okay, let me try and find another question that is worth talking about. Okay, I was discussing this in class with my teacher. Okay, I wanted to do this one actually. Okay, name process 1. So process 1 is from alkene to alkane. So process 1 is hydro. Wait, I'll just write it here lah, because it's better. AI. Okay, let me just make my handwriting pretty. Hydrogenation. Doesn't it look so good now? Okay, I2. What is the reactant? So the reactant is basically, oh, what's it again? We have two things, reactant and product. So you have to mention what reacts with the alkene to what reacts with ethene to produce ethane. So it's hydrogenation. It's hydrogen gas. You write this one out, hydrogen gas. B. What is the chemical equation for process 2? So process 2 is since it has OH here, it is hydration. So the process is H C double bond C H like this, and then wait. Oh yeah, I don't have to I don't have to write the structural formula. I just write it as normal. So let me just try and undo. Okay, so the formula is C2H4 plus H2O reaction produces C2H3OH. Yeah. And then the reactants are H3P, I mean the catalyst is H3PO4, 300 degrees Celsius and 60 atm. I think that's I think that's the correct answer. Let me just double check. Yeah. And then this is gas, this is steam, and this is liquid. Let's I, and then what's the reaction conditions? So the reaction conditions is this one, phosphoric acid as catalyst. You write it as acid as catalyst, and then heated at 300 degrees Celsius and 60 atm. Okay, that's B. Now C. C is about process 3. So it turns moist blue to red. So if it turns blue to red, it is acid. So it has to be a carboxylic acid. Since it's 2C, so it will be ethanoic acid. And then oh wait, I'm wrong here. I read the wrong question. Oopsies. Okay, what is the product for process 2? Ethanol. Okay, so that's I. And then what's the conditions? What's the conditions again? Reacts with oxidizing agent such as KMNO4. I think that's, I forgot if you have to add anything else. I don't think you have to. Let me double check. I'm overthinking again. Oh yeah, you have to we have to put acidified. You have to write the full name. Acidified potassium manganate. Oh my god, my handwriting is so ugly. Okay, potassium manganate 7. You have to put acidified at the front. So I think that's the only condition. Okay, okay, wait. Come back. My brain froze. Okay. In process 4, compound Q gives a fruity smell. So the structural formula is, on the left is, okay, it produces ethyl ethanoate. So on the left is carboxylic acid. So it's C, C, H, 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 and then C double bond O, and then O, and then on the right is C, C, H, 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 H. I think that's how you read it. So this is ethyl ethanoate. Okay, what's the catalyst? The catalyst is concentrated sulfuric acid. Yeah, let me just see if I can find the question again. The equation, I mean. Yeah. This is the only, wait, it has to be heated also. Okay, process 5 is a combustion reaction. So write the chemical equation for the reaction in process 5. This one is easy. So it is C2H5OH plus O2, CO2 plus 3H2O. So it is 473. Yeah, I think that's all. Okay. Wait, now I want to talk about another question that my friend actually sent me. I don't know if I can transfer it into the drive. How? Okay, so my friend just told me, when it comes to reflux is normally under oxidation of alcohol and esterification. So let me go and check on my book, because I can't study alone. Yeah, ethanol is heated under reflux at 170 degrees Celsius with excess sulfuric acid. Oh, wait, no, that's something else. Oxidation of alcohol. Wait, no, it is. My bad. Hey, wait, no, it's not. Okay, you're just hearing me talk right now. Does it actually undergo reflux? I don't think it undergoes reflux. Yeah, I'll go ask my friend again. Oh, I think he means oxidation of alkene. Yeah, oxidation of ethene. I think he means by that. Oh, wait, no. Oh, no. It's fermentation of glucose. Yeah, it's fermentation of glucose. And then the other one is esterification. Yeah, I think I had a feeling about this one. Like, to get pure ester, you need to do reflux to get pure ester, if I remember correctly. Oh, yeah, he is right. When you react ethanol with an oxidizing agent, you heat it under reflux, and then you can produce then you can produce carboxylic acid. Okay, so I guess my bad. I guess we know what the refluxing is now. I guess, yeah. Wait, I have one more question that I remembered. Teacher teaching in class. Okay, so they'll give you like an equation kan. So let's say like, I'm gonna close this. Okay. I'm gonna close this, and then I'll put CXHY plus x plus y over 4O2 becomes okay, wait, let me make it look prettier first. That was my bad. Okay, CXHY plus x plus y over 4O2 XCO2 plus over 2H2O. Okay, so it says 10 cm cube of hydrocarbon, so this is 10 cm cube, requires 50 cm cube of oxygen to produce 30 cm cube of carbon dioxide. Okay. So the way you solve, so how do you determine the molecular formula? You have to determine what CXHY is. So first of all, you need to try and make it into a ratio, I guess, because these are all in gas, so you can actually classify them into since they're all in gas, you don't have to like change it into molar mass and then find the ratio there. You can just immediately use this as your ratio. So it's 1, 5, and 3 because it's the lowest ratio. If it's mass, you need to try and change it into to moles instead of immediately turning it into ratio. Like if it's like 10 gram, 50 gram, and 30 gram, you have to change it into mole because molar mass. Because for molar mass, each compound has their own molar mass. But for gases, every single gas compound has the same volume per mole, which is 24 dm cube. So since they all have the same ratio, you can immediately put it as 10, 1, 5, 3. And then next is so you now get 1 mole of CXHY reacts with 5 mole of O2 to produce 3 mole of CO2. So now you know that X equals to 3 because 3 mole. And then you know that X plus Y over 4 equals to 5 because 5 mole. So X plus Y over 4 is 5, this is 3. You know that X is 3, so it is 3 plus Y over 4 equals to 5. Don't write like me, okay? So Y over 4 equals to 2, Y equals to 8. So your answer is C3H8. So yeah. Okay, now the last question that I wanna talk about is sometimes they will give you the formula. Yeah. There was a question that I remember teacher talking about, but I don't know how to explain it. It's a very good question though, because it does test your care butt a bit. So what happens is, they say that they say that it is heated under excess oxygen. Wait, I'm just gonna find the thing in the Google Classroom. Sorry, teacher. Let me just don't look at my mocks. I think it was this one. Oh no, this is the test. Wait. We did it in class. I'm gonna borrow her thing for a while. Oh, this is an old chapter. Oops. This is a very old chapter. Why am I in Redox? Yeah, you're looking at me finding questions right now. Oh my god, it actually has been a while since we done. Well, I think it's alkane punya reaction. Is it? I don't know if it's still here. Okay, I think I'm wasting a lot of time. I guess you can leave the video now if you want. I'm gonna try and find this thing by going to the UEC. Oh, well, I guess while I'm here, I'll just talk about alkynes, because alkynes are a pain in the ass. So first of all, the only thing that I like to remember about the properties of alkane, alkene, and alkyne is the type of bonds they have. So it says here, the first one here is alkane. The second one is alkene, and the last one is alkyne. So alkane's electronic configuration is S3p hybridization. For alkene, it is sp2 hybridization. For alkyne, it is sp hybridization. As you can see here, sp. So hybridization, from what I understand, is like they combine together to form one mega atom or something like that. I'm not so sure. Excuse me. And then they form a special shape because they have to like have a gap between each other. So sp3 hybridization or alkane, they have a tetrahedral shape. For sp2 it is trigonal planar, or for sp it is linear. And then there's also the bonds. There are two types of bonds: sigma bond and pi bond. So sigma bond is basically what we call side by side, while in the mid, basically they mostly occur in the middle, while pi bonds are weaker bonds and they occur head to head. So you know, it depends on how you interpret it. Like the ends, if you call the ends the head, so it will be head to head for sigma bond and side by side for pi bond. But yeah, basically from what I understand, sigma bonds happen in the middle while pi bonds happen at the sides, and pi bonds are weaker than sigma bonds. And sigma bonds are what in alkane they only have sigma bonds, while alkenes have one sigma bond and one pi bond. Alkynes have one sigma bond and two pi bonds. So there's a few reactions that teacher talked about, and I think the one that I'm gonna focus on would be what's it called again? There is one that teacher mentioned a lot. No, teacher mentioned a lot. Teacher kind of emphasized. Oh yeah, this one, Lindlar catalyst. So basically, hydrogenation of alkyne to become alkane. So how does it become alkane? You have to undergo hydrogenation twice. So first stage is to break one bond to become alkene. Second stage is to break a bond again to become alkane. And the catalyst is called Lindlar catalyst. So this is the only thing that I remember about the reactions. And Lindlar catalyst is actually either palladium and lead oxide, or wait, is it palladium? Yeah, this is palladium. Palladium and CaCO3. So yeah, that's that. And then they also undergo halogenation. They also go hydration, but their hydration is a bit more patterned. They also undergo reaction with hydrogen halides. No, not hydrogen halides. They actually undergo reaction, They do undergo reaction with hydrogen halides. And this is the Markov-Nichols rule I was talking about last time, where they will choose the place with more hydrogen. So that's why the Cl would pair up with the other Cl. So because this other H will choose the part with more hydrogen atoms. So Cl will be together and the hydrogen will be together. So it is 1,1 dichloroethane. But yeah, basically the similarities between alkene and alkyne is basically the same, but it undergoes the same stage twice to become alkane, to become single bonds. And then here are the very special reactions. This is the cold alkaline KMnO4. Last time it was acidified. This one is alkaline. The red star is not coming in an exam, but I don't like talking about this anyway. And then here, synthesis of alkynides. So alkynes react with ammoniacal solutions of copper 1 salt or ammoniacal solutions of silver salt to form precipitates of copper 1 acetylide or silver acetylide. Yeah, I don't like talking about this one. This one is a bit too hard for me. So during exam, I'm going to open this slide and just write down whatever teacher asks for. Yeah, I'm not studying this. I mean, I'm not memorizing this. This is a bit too much for me. I mean, if it was exam, I would. But yeah, and then last one is methane. You heat it up with steam, and then you will get ethine, or the common name is acetylene. So this is the whole process, you know. Yeah. I don't know what's the top part, but the part at the bottom is basically how to get acetylene now. But yeah, this is mostly for UEC syllabus, and I'm not taking UEC. At least I don't think I will. So that's why I'm not gonna talk much about it. Yeah, let me go and see if I can find this question I was talking about now. Yeah, basically it's mostly all the same. The other thing that they mentioned is cycloalkane, but everything else is just the same catalyst, like hydrogen. Wait, no. No. My bad. They won't actually talk about this one, if I remember correctly. They'll just talk about cycloalkanes in general. But oh yeah, this one, free radical substitution. So basically, they explain halogenation more interestingly. So yeah, there are a few steps: initiation, propagation, and termination. I'm not gonna talk about what this thing actually means, but basically, initiation is the electrons get triggered to release, and then propagation is what the chlorine goes to the methyl radical, while the initiation is the chlorine releases electrons, and then propagation is basically the chlorine combining with the methyl, the radical, like the basically when it switches place, that is propagation. Like when it switches place with one of the hydrogen, that is propagation. And then termination is basically to stop the process, to stop converting into to stop converting into what was it again? To stop the process of substitution. But yeah, they explain it a bit more interestingly, and it's something that I don't like talking about. So, yep. It's something I hope you guys understand this. But based on what my teacher told me, you just have to know at least what the steps are: initiation, propagation, and termination. You don't have to know what the heck homolytic fission is and so on. But yeah, free radicals are removed and the propagation step is stopped. Yeah, I'm not going to explain this because I'm not good at it. They're good at it. Oh, here it is. Yeah, this one. Okay, I'm gonna screenshot this, and then I think if I pin this, yeah, 20 cm cube of a gaseous hydrocarbon was mixed with 150 cm cube of oxygen. The mixture was sparked so that the hydrocarbon was completely burned. The gaseous products have a total volume of 130 cm cube. When this product was passed over soda lime, the volume of the product decreases to 90 cm cube, and all gases were measured at standard temperature and pressure. So basically, they're all at the same pressure, so you don't have to so they're all the same ratio. So what is the molecular formula? Okay, first of all, it says that the hydrocarbon was completely burned. So that means that there could be excess oxygen. All of the hydrocarbon is used up, but there also could be excess oxygen. So yeah. Okay, the thing is this CX plus CXHY plus X plus 504 thing, this is a formula that came from the UEC syllabus. So this is how you solve equations regarding hydrocarbons. X is the number of carbon atoms while Y is the number of hydrogen atoms. This is in the UEC textbook. And because I'm not going to memorize this because we're doing open book anyway, but it's just worth noting that this can be used for all hydrocarbons. So it says here, the hydrocarbon was completely burned. That means we might have excess oxygen, but all 20 is used. Next, when the product was passed over soda lime, the volume of the product decreased to 90 cm cube. Now, soda lime's function is to absorb carbon dioxide. So when you have 130 cm cube going over soda lime and you only have 90 cm cube left, the 40 cm cube is actually carbon dioxide. Why? Because 40 cm cube is absorbed by the soda lime. Because as I said, soda lime is absorbing carbon dioxide. So when it absorbs carbon dioxide, when it absorbs carbon dioxide, wait no. Let me see. Wait, no. I forgot. Which one does it absorb again? Oh yeah, I think it was carbon dioxide. Wait, no. Okay, I got it messed up. It's not carbon dioxide. Soda lime is, what was it called again? Deliquescent. So it absorbs water, if I'm not wrong. Soda lime, let me just Google this just in case. Soda lime absorbs carbon. Oh wait, no, it is carbon dioxide. Wait, is it carbon dioxide? Okay, I'm getting confused as well. Okay, yeah, soda lime is CaO. No, that's quick lime. NaOH. So it, okay. Wait. Okay, yeah. I got confused. It does absorb carbon dioxide. Okay. Back to this. So since soda lime absorbs carbon dioxide, and the thing decreased from 130 to 90, 130 to 90, it means that 40 cm cube was absorbed. And since it only absorbs carbon dioxide, then all 40 cm cube is carbon dioxide. So we have 20 and we have 40. And then okay. And then this 90 is okay. Oh wait. When we have reacted this gun, we assume that the H2O became water. So there's only two things left in the reaction: carbon dioxide and oxygen. So that means if 40 of the 130 is carbon dioxide, then the remaining 90 is actually oxygen. So we have 90 cm cube of excess oxygen. So how do we find out how much is used in the reaction? We minus the number we had at first by the number we have now. So 150 minus 90 is 60. So remember, this 90 is the oxygen that we have left, because remember, the oxygen is in excess, so we have extra. And there's only two gases in the product, which is carbon dioxide and oxygen. At first, it's only oxygen, but after that, it is oxygen and carbon dioxide, and then this 90 is only oxygen. So 60 cm cube is reacted. So now we have ratio 2, 6, and 4, which is basically 1, 3, and 2. So if you put So if you put x equals to 2, wait, no. Okay, apparently you have to divide by 10. I don't know if you can actually simplify it to the simplest ratio. Let me check. Okay, I have to ask you about this again, but to be safe, I'll just divide everything by 10. Then you write x equals to 4, right? Because divided by 10 is 4 ma. So it's 2, 6, 4. Then x plus 5 over 4 equals to 6. And then, yeah, y equals to 8. So what is the importance of this 20? Like, why is the 20 so important? Because, wait. Okay, yeah. Teacher might be wrong actually. Actually, wait, never mind. I'm the one that's wrong. So to be safe, I'll just divide by 10. But if I were you, I would pray that this question does not come out in exam. But if it does, good